Mayaz on behalf of Team Zenflow. Today we are going to talk about our hydrogen solutions based on our problem statement. So, first of all, let me take you to the hardware and the logistic solutions. So, these are our hardware and logistic solutions. First, it consists of the mass storage solution where we have three components. First component is the AI optimized salt cavern system. This is projected to reduce the cost from $2.50 per kg to $1.20 per kg. Then our second component for this master solution is compression systems. As we know, compression systems are a major factor in storage of hydrogen gas. So the solution by our team is that if we use variable pressure, then we can significantly reduce the cost for storage from $1.75 per kg to almost amount of $0.85. Now, um, the third component for our storage system is our enhanced metal hydride storage. If we use metal hydrides as compared to the other metals used right now, then we can reduce. It's projected to reduce the cost from $8 per kg to almost $3.2 per kg. These all metrics have been verified and tested. Now let's talk about the second solution, which is the distribution system. So for distribution system, again we have come up with three components. One is fiber reinforced polymer pipelines. Nowadays and currently the pipelines have which have are used are made of steel, which poses a great issue to the current distribution systems, and which increases the cost, and we have high leak rates due to small molecular size of the steel pipelines. So if we use fiber and reinforced polymer pipelines, then these issues can be overcome. So the current cost is $2.5 million per mile, which it can be significantly reduced to $1.2 million per mile if we use fiber reinforced polymer pipelines. Secondly, zero boil off transport. Usually, when right now the system which is going on for the transport, it has significant issue for of boil off losses, and the transport efficiency is only 60 to 70%. So if we use as we are showing here, if we use zero boil off magnetic refrigeration, then there is no losses due to boil off, and efficiency goes up to 98%. And along with that, our cost is reduced by 68%. And current cost is $13 per kg. Our If we enforce this zero boil off transport, then the cost reduces to almost $4.20 per kg. Now let's talk about the monitoring limitations. Current monitoring limitations are slow leak detection. It takes almost minutes to almost hours to detect the leak detection nowadays, and the real time data are is limited for the um, hydrogen leakage. So now AI from Team Zenflow, we have IoT sensors with machine learning for predictive maintenance and instant leak detection. If we use a CNN LSTM model to uh, predict the leakage uh, by taking past inputs as our data, then we can significantly reduce the false positive rate from 5.5 to 15% to less than 0.1% if we use real-time IoT sensor networks and AI leak detection algorithms. Okay, so that is all. This is basically the market analysis, and these are the graphs. These are our competitive advantages. We have first mover advantage, proprietary FRP technology, zero boil off systems, digital twin platform, which I'll show you right now, and this implementation in the hardware reduces the cost from at least by 70%. Now let us talk about the software systems which we have built. So first is our dashboard. So this is the dashboard which will be integrated into the hydrogen plant using any IoT software. So this is the levelized cost of hydrogen, which is $2.85 per kg, which is our target. Because right now all the hydrogen cost per kg. Uh, so right now the current metric for hydrogen made per kg is more than $3, but Zenflow have has reduced this cost from $3 to at least $2.85 per kg, which is a very significant amount when it comes to mass production of hydrogen. This is our system. This is the current real-time hydrogen production input. We can change this from last 24 hours to last 1 month. We can check for last 2 months also and compare what is the hydrogen output as compared to the input. This is our core status, which is updated every uh, hour, which gives the AI core status, which has an AI API integrated in it, and it gives us insights based on the current weather and the current weather forecast going on. This is the 5-day renewable yield forecast. For example, today Monday we can get 95% yield, and on Wednesday 88% yield because it's a windy condition. Thursday there's supposed to be a heavy downfall of rain, so the yield gets reduced to 60%. And these are currently based on the weather API which we have gathered from the internet. This is operational log, which is updated every 10-15 minutes, and these are CDM alerts, MPC, our MPC predictive model, SCADA, and everything. So now let us get to the our AI engine, which basically is the same as the interface, but one thing which has been integrated is this is like the live production monitoring. You can see as per the current time going on. For example, now it's 8:22 p.m. in India. So according to that, the hydrogen production kg production rate has is being monitored accordingly. This is the live weather data, which is wind, temperature. This live weather data helps the uh, helps the system to understand how we can optimize the production of hydrogen according to the weather. These are the AI recommendation. This is the AI recommendation block, which recommends when not to turn off the system and turn off the electrolyzers, when to turn off one electrolyzer, when to turn off when to turn on both electrolyzers. This ensures the less wastage of electricity, and so that we can produce hydrogen more efficiently and in a better manner. So here we have our AI conversation bot. You can ask questions here. For example, let me ask about the weather optimization. What is the optimal production schedule? Now our AI assistant answers based on the current weather conditions. You can ask about maintenance status also. Here basically we are talking mostly both about the electrolyzers, because electrolyzers are an important component when it comes to hydrogen production. So we have filter saturation, we have preventive action, all these integrated into AI assistant, which can help the workers to understand when and when not to turn off and turn on the system based on the weather. So now let me take you to the next component of our software solution, which is the PEM stack monitoring. So PEM stack is our membrane which is present in the electrolyzer. This component is very important in the electrolyzer, because this is what differentiates the electrolyzer from the other systems currently used. So as we can see, this is the VI curve for the electrolyzer. The more the curve gets towards the current density, the more the cell voltage increases. This means the electrolyzer unit is working fine, and if there is any uh, if there's any fluctuation in current density or cell voltage, if uh, if there's any fluctuation in current density and cell voltage, then our proactive shutdown system shuts the system down to prevent any type of issues or any leakage, anything. We also have integrated BESS, which is battery energy storage system, which compensates for more than 15% renewable energy fluctuation. And the last component of this is our digital twin system, which uh, which basically is integrated into the software using an IoT device, and we can simulate other you can simulate situations or scenarios based on the weather input. For example, now we are at scenario number 3, which is the case of extreme wind fluctuation. So uh, based on the current weather scenario, we can see the real world baseline is very vulnerable. But uh, if we turn off one electrolyzer, for example, it's shown, if real world efficiency, if we turn off one electrolyzer, then our efficiency can be moved up to 45%. And for this we can learn extra optimization also. We can integrate many scenarios here, and we can run as many scenarios as we want. Now the scenario is of extreme wind fluctuation. We can generate scenarios for low, if there is any rainfall, if there is less wind, if there is if we can also include instances where there is high levels of humidity or less levels of humidity. So, and due to this scenario, we can expect a 2.1% boost, which is achieved by dynamic BESS slash electrolyzer load management. So that is all for our solutions.